Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about equivalence relation. In our previous classes, we clearly discussed about symmetric, reflexive and anti-symmetric, these properties. Please watch those classes and come back here. The link for the playlist is provided in the description below. Coming to today's class, so a relation is said to be equivalence when we are going to say that it is an equivalence relation if it satisfies. It has to satisfy three properties: reflexive, symmetric and transitive. If it satisfies all these three properties, then we say that the relation is an equivalence relation. Let's try to take an example and understand it better. Let's take a set A is equal to set of all real numbers. So our set is all the real numbers, means all the numbers from minus infinite to plus infinite. So on this set we are having a relation R is equal to A comma B, the ordered pair A comma B, and it has to satisfy A minus B is divisible by 5. This is the condition it has to satisfy. Those ordered pairs you have to take A comma B. So is it an equivalence relation? Yes, it is an equivalence relation. Let's try to understand why it is an equivalence relation. So it has to satisfy three properties. What is the first one? Reflexive property. What's the reflexive property says? You take any x that belongs to the set X, here set A, from the real numbers. You take any number from the set. You take 1, 2, 5, 10, 11, any number. So A comma A should belongs to our relation. Means if you take 1 minus 1, A comma A means 1 comma 1, 1 minus 1, 0, divisible by 5. So it is there in our relation. You take 2 minus 2, 0, divisible by 5. So you take any number 1.1, 1.9, 10.9, 10.9 minus 10.9, which is 0, divisible by 5. So it is satisfying the property of reflexive. So the first property it is satisfying. Check the next property. Is it a symmetric relation? Yes, it is a symmetric relation. What is symmetric relation? If x comma y, means if x comma y is an ordered pair that belongs to our relation, then definitely y comma x should be in our relation. If it satisfies this property, then we say it is a symmetric relation. Let's check it is satisfying or not. Let's take an example, 1 comma 6. So 1 minus 6, which is minus 5. Minus 5 divisible by 5. Yes, it is divisible by 5. If 1 comma 6 satisfies, 6 comma 1 definitely satisfies. 6 comma 1 means 6 minus 1 means 5. If it is negative 5, it is positive 5. So 6 comma 1 definitely will be there in our relation. If x comma y is there, y comma x definitely will be there in our relation. So it is satisfying the property of symmetric. Last one we have to check for transitive relation. What's the transitive relation means? If x relates y and y relates z, then x relates z. If these two conditions satisfies, then definitely it has to satisfy this x relates z. Take an example, 15 comma 10, 15 minus 10, which is 5, divisible by 5. 10 minus 5, which is 5, divisible by 5. Then obviously 15 minus 5, which is 10. 10 is divisible by 5. Obviously 15 comma 5 will be there in our relation. If x comma y, y comma z is there in our relation, then definitely x comma z will be there in our relation. So that's why it is an equivalence relation. It is satisfying all the properties. Let's take one more example for better understanding. Let's take the set A comma B, and from this set we are taking S is equal to set of all subsets of a set. These type of examples we already done in our previous classes, hoping you already know what is this set of all subsets of a set. Set A comma B, phi A B AB. These are the set of all subsets of a set. On this set we are having a relation R is equal to S on this set, comma, what's the relation symbol? Subset. Is it an equivalence relation? No, it is not an equivalence relation. Why it is not an equivalence relation? It has to satisfy three properties. What are those? Reflexive, symmetric, transitive. Is it satisfying reflexive? Yes, it is satisfying reflexive. You take any element from this, phi, subset of phi, A, subset of A, it is satisfying that. B, subset of B. So it is a reflexive relation. Is it a symmetric relation? No, it is not a symmetric relation. Why it is not a symmetric relation? You take any ordered pair x comma y, phi comma A, phi subset of A, but A not subset of phi. Opposite is not, it is false. That's why it is not satisfying symmetric relation. So that's why it is not an equivalence relation. This is how we need to check the equivalence relation. So hope you understand these examples. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.